Hi. So previously we discussed the consumer's theory or the demand theory, but at individual level. Okay. So today we're gonna in this episode to discuss the consumer's theory, but at a aggregate level. Okay. So when we're summing up or we're aggregating over all those individuals of the consumers, can we also talk about the weak axiom of the river preference over those aggregate level of the demand? And if not, then what conditions we might need to have the those axioms held? Okay, so those are the questions that we're gonna ask today. So now let's get started. So this will be the fourth section in the on the textbook, which is called aggregate demand. Okay, so and one reason that we're studying the consumer theory is to try to understand the aggregate level of the behavior, right? So that would be also a very important topic in the studies of economics. So in this chapter number 4, then we're gonna investigate some consumer theory, right? As we mentioned before from the previous 3 chapters, where we apply those results to the aggregate demand. Okay, and especially want to check, can we also derive the weak axiom for the review preference at the aggregate level? Okay, so so the first question that we're gonna ask is that given that individual demand can be expressed as a function of prices and individual wealth level, so we're gonna ask that what can aggregate demand be expressed as a function of prices and aggregate wealth? Okay, so when can aggregate demand be expressed, okay, as a function of prices and aggregate wealth? Okay, and sometimes we might face some problems of reallocations, right? So if we exchange or if we reallocate the wealth to make some new distribution over the wealth among the people, so you also want to ask that if this distribution of the wealth is changed, then what can we still have this the same result as we had before, or can we have the weak axiom of the real preference, right? So the second question will be that given that individual demand derived from the rational preferences, okay, and which is satisfying the weak axiom of real preference. So given the individual level being rational, so we're going to ask that when does the aggregate demand satisfy the weak axiom for these? So it means that if the how when is this aggregate demand satisfying the rationality requirement, right? So when does aggregate demand satisfy the warp? Okay. Okay, so we just use this warp. Okay, good. So those are mainly the two questions that we're gonna to discuss today. Okay, so first let's begin with the definition for this sort of the aggregate demand and aggregate wealth. Okay, so we say that suppose that there are capital I number of consumers with rational preference relation, and for each consumer, okay, and the corresponding worth and demand function, okay, xi p wi. Okay, so given the price, okay, so we're gonna have the same price shared with all the consumers in L dimensions. Okay, and the wealth levels from W1 up to Wi. Okay, So the aggregate demand is written as a worsen demand of the same price P and taking all those wealth together, okay? And so we just aggregate all those wealth in the same demand here, and this would be the summation for all those, across all those individuals, and where we have the individual level of the worsen demand. Okay, so the aggregate demand, it depends not only on the prices, but also on the specific wealth levels of the consumers, right? So we ask, when we are justified in writing the aggregate demand, if we want to write in the simpler form, let's say P of summation over W's. So here, this aggregate demand, it depends only on this level, the aggregate level of the wealth, right? So for this to hold, then the aggregate demand, it has to be identical for any two distributions of the same total amount of wealth across the consumers, right? So that is for any aggregate wealth and another distribution, of the aggregate wealth. Let's use a prime, W1 prime, up to WI prime, to denote the distribution. So the total amount of the wealth in this environment, it doesn't change. Okay, we just redistribute. Some people might get more money, but some people, they might get less. Okay, such that the summation over WI is still the same as WI prime. Okay, then here we have the aggregate demand to be the same under two different distributions of the wealth. Okay, so that's what we're going to ask for, right? So we want to ask that when this condition is satisfied, right? And we want to consider starting from some initial distribution from this W1 up to WI. So a differential, a minimum or a very small change, a differential change in the wealth. Okay, and it should be satisfying all those, the summation of all those changes to be zero. Okay, so we start to examine this above equality here. We start from, so we want to discuss the conditions that they're gonna be satisfied for the above inequality, equality, right? So starting from initial distribution, let's say from WI up to WI, W1 to WI, and there's gonna be a differential change in wealth. So it'll be the W1 up to the WI. Okay, this is too big. Okay. So there'll be just some small change in the wealth for each person. Okay, and this has to be the summation of all those small changes equals zero. Okay, so if aggregate demand can be written as a function of the aggregate wealth, then we're gonna assume the differentiability of the demand functions. Okay, and we must have the summation over I. So we take the partial derivative of the worsen demand for the nth dimension and for the ith person. Okay, and with respect to WI, and multiplied by this minimum differential change, and this is zero for every dimension of L. Okay, so this can be true for all redistributions as we mentioned. Okay, dw1 up to dwi satisfying the summation to be 0. Okay, and from any initial distribution, if and only if the coefficients of the different dwi's, they're equal. Okay, so that is L I P I over. So this derivative has to have the same slope as the jth person, right? And we wanna, and this is for, again, for every dimension L, okay? And for every two individuals, I and j, and this wealth from W1 to Wi, okay? So we're gonna use a little figure to illustrate the intuition of this condition here, okay? So this is talking about the slopes of those wealth expansion path, right, for two consumers. So here we have this x1 and x2. Okay, so let's suppose we have some budget. Okay, so this is the budget for consumer I on the price P, and we have some indifference curve here. Okay, and if we have some budget, let's say this is the budget for the price and WJ, and then let's say the indifference curve for this jth person is something like this. This is too far from this curve. Okay, it should be tangent. Okay, and then what we were talking about for this equality of those two slopes are just the same slope or the parallel straight lines for those wealth expansion path, right? So for example, we have this and this. Okay, so this is the wealth expansion path for ith person, and this is for jth person. Okay, good. So this is just the expressing this parallel straight lines for this wealth expansion path for two different consumers, right? Where we have this condition to hold. Okay, so and intuitively for any fixed price vector P and for any good L, so the wealth effect at price P must be the same, whatever consumer we look at and whatever the consumer's level of wealth, right? So next, we're gonna introduce a proposition. Okay, so that'll be the proposition on the textbook 4.b.1, where we're gonna have a representation for the interrogativity function, which is called Gorman form. Okay, and that'll be used for us to show some results related to the aggregate demand later. Okay, so we say that a necessary and sufficient condition, let's see, for the set of consumers to have parallel and straight wealth expansion path at any price vector P is, so this condition is that preferences admit indirect utility functions of Gorman form, okay, with coefficients on WI for WI the same for every consumer I. Okay, so in Gorman form we have a representation for the indirativity VI to be just two parts. So the first part would be just a function purely on this price, and the second part will be a product of the function of price multiplied by the supply. Okay. All right, and it'll be not difficult to prove this sufficiency and the necessity, okay, for this statement here. So, and we will follow the textbook and skip this proof, and you can check this for your own interest. Okay, good. So then we have this Gorman form, okay, and we're gonna later to use this, and to also to further talk about the second question that we asked in the beginning of the episode, that is the to discuss the aggregate demand related to the weak axiom of the review preference. Okay, good. So then we're gonna ask that to what extent do the positive properties of individual demand carry over to the aggregate demand function. Okay, and we can see that the continuity and homogeneity of degree zero and Moore's law they hold as well, right? So here that we're gonna focus on the conditions under which aggregate demand also satisfies the weak axiom of review preference, okay, which is the important part of the consumer's theory. Okay, so let's directly go to the definition of 4.C.1. Okay, so we say that the aggregate demand function XPW, so this is referring to the aggregate demand, okay, satisfy the warp if the price in a product X P prime W prime less than or equal to W and X not the same as X P prime W prime. If this imply the other one doesn't hold, right? So this will be exactly the same as before for the warp. P prime inner product X P W, this doesn't satisfy the budget. But this is, everything is at aggregate level, right? For any P W and P prime W prime. Okay, so this is just the definition for the warp at aggregate level, right? So aggregate version of the warp. Okay, so and you wanna ask a very natural question that why it is not that the aggregate it is not that the warp is automatically carried over from the individual level to the aggregate level, right? So can you give any failure case of that? And indeed we can, right? So, and this would be the example in the textbook called 4.C.1. Okay, so this would be a counterexample or a failure of the aggregate demand to satisfy the warp, right? So it is not satisfying the warp here. So fail to satisfy warp in aggregate demand. Okay, but at individual level, the warp holds here. Okay, but at aggregate level, it doesn't. So let's have a look on this example. Okay, suppose there are two goods and to individuals, okay, to consumers. And the wealth is distributed equally, okay, so two people, they have the same W/2 amount of money, and this W is the aggregate wealth, right? So the price vectors P and P prime, okay, with corresponding individual demands under, so that'll be x1 P half of W and x2 P half of W, okay, under this price P. And if we have P prime, and that would be if the price change, then we have this correspondingly denoted as P prime W/2 and x2 P prime W/2. Okay, so let's have a figure for this little problem. Okay, so it's two-dimensional, and let's suppose the budget for one of the person. Okay, this would be the budget for, actually it's the same for the two people, right? Because they have the same amount of wealth. So this is the price P and 2/W. Okay, and suppose if the price change, then we have a different budget as this. Okay, and this will be the budget of P prime and W/2. So those are two different budgets, okay, with a price change. And let's suppose we have this x1 here, okay. So this is the x1 with P and W/2 here, and x2 of P prime W/2 here. And this would be where the, okay, and let's say we have x1 P prime W/2 here, and somewhere here let's have this x2 P W/2 here. Okay, so at the individual level, we can easily verify that this each consumer satisfies the work, right? And there's nothing strange here. But at the aggregate level, okay, so let's label all those midpoints, okay. So that's this blue one will be the midpoint for under the price P prime, and the red one will be the midpoint for the price P. So this will be half of x P W/2, and the blue one will be half of x P prime W/2. Okay, so there'll be an immediate problem, right? So you can see that the red and blue, those two dots, they do not satisfy the work. Okay, whenever you see this kind of shape, those kind of budgets and those consumption, those wants and demands, then you see that the warp is violated. And you're gonna ask why the warp is violated here, and it'll be very easy to verify, right? Because, for example, if we have this blue dot here, that is the under the price P prime, but that is, we can see that this is under this line of the budget with price P, right? So this has to be affordable, but here, the given the other price, it is not. It's not selected, but instead the red dot, it is selected, right? And it also true for the other way around. So then this violates the weak axiom of review preference, right? Okay, so, and we're not going to write all those explanations, but you just see the intuitions of this, right? Okay, so then we're gonna talk about the conditions that we need to satisfy the warp at the aggregate level. Okay, aggregate demand. Okay, so that'll be, but we might need something else, some definition for this proposition. Okay, so let's put the definition first. So some property that we're gonna need, that is called the uncompensated law of demand, ULD. Okay, so we're gonna say that the individual demand function, so we just use the expression. So the individual level of the demand function satisfies uncompensated law of demand, ULD, if we have the following. Okay, so this ULD is saying that if we have the product, the inner product of the price difference with the difference of the worth and demands, okay, and this has to be less than or equal to 0, okay, for any P prime and Wi with strict inequality if the axis in different prices are not exactly the same. Okay, so this is the individual level version of this ULD property. Okay, and it is analogous to aggregate level of the demand function x. Okay, good. So next we're gonna use this property of ULD to establish this warp for the aggregate level. Okay, so that's gonna be the proposition 4.C.1. Okay, so we say that if every consumer's worth and demand function xi p wi satisfies this ULD property, okay, and the aggregate level will satisfy. Okay, so that's the aggregate demand. And this is not difficult to prove for the first step because we just sum all across all those individuals, and that will give us the aggregate level. Okay. Okay, and as a consequence, the aggregate demand satisfies warp. Okay. All right. So now let's go through this proof. Okay, so we're gonna consider two situations. So the first one will be the price P, and another one will be P prime, but with the same W. Okay, and here we're gonna say that the X in PW and P prime W are not the same. Okay, so here from this we must have that XIP alpha IW not the same as XI P prime alpha IW. Okay, for some I. Okay, and then we simply sum the ULD. Okay, summing the ULD over the individuals over I, then we immediately get the aggregate level, right? P prime minus P inner product X at aggregate level minus the X. okay, less than 0. Okay, and this holds for all the p prime and w. So that's easy for the first step. And the next will be proving the warp, right? So to show the warp, okay, so we take any pw and p prime w prime with the demands are not equal, and this p inner product x taking p prime and w prime is within the bundle, okay, in aggregate level. And then we define a p double prime, okay, to be something related to this p prime, but with a coefficient of w over w prime, okay. So by homogeneity of degree 0 in the worth and demand, okay, we will have that x p double prime w to be the same as xp single prime w prime, okay. And then from the aggregate level of the ULD, so this inner product with the difference of x, the first one will be taking this double prime as p, the second one will be no prime, just the p, so this is less than 0, okay. And also something that we had before just right now, so that would be this p xp double prime w less than or equal to w, okay. And we're also using Moore's law, okay, so it gives us this p double prime inner product xp w, which is greater than w, okay. And then we just plug this p double prime back in, so that gives us p single prime x p w greater than w prime, and that is exactly the requirement of this warp, right? Okay, and then later in the proposition 4.c.2, and it gives us the a condition when the URD is satisfied, right? It just says that if this preference relation is homothetic, okay, and you can see the proof and some explanations of that on the textbook. Okay, good. So so in this episode we discussed the aggregate level of the demand, which is based on the individual consumer's theory, and we gave a counterexample when in some situation where we satisfy the warp for the individual level of the demand, but it is failed to hold for the aggregate level, right? And then we showed some conditions that we're gonna need, which is called ULD property, between the differences between the price and the worth and demand, for that to be used for us to prove it is the case that we have this aggregate level of the warp, okay. So those would be everything about the consumer theory, right? And next we're gonna go to the production theory. Okay, good.